All right, now that we've learned about the concepts of comparing or analyzing categorical to numeric relationships, let's do this in Python. So I want you to go to the book in 17.5, or whichever chapter yours includes the bivariate categorical to numeric stats. And in the Python section, I actually want you to scroll down and let's copy this section right here from this second block that includes some data and some means. So right here we go. The data here is in a different form than you're used to. Actually, back here in the book, I want to scroll down and show you the original data that looks like this. We've got a categorical column of various levels of education and then an annual income, and we want to see if there's a relationship between these. But in order to do that, we have to change the format of this data so that each unique group is a column or a list, and then we put the values of income associated with each of those in each one of these lists. So for example, this record right here of this person with a bachelor's degree and 90,000 in income, that is represented right here. Here, 7 graduate degree with 60,000, that's this one right here, and the last graduate degree with 80 down the bottom. So anyway, we get the data in that format first, and I'm going to show you how to do that in a little bit later. So for this example, I'm going to just give you the data already in that format, just copy and paste. Down here, we have, we're just printing out the means of each of these lists. So I imported both SciPy to do the t-tests and then import statistics to create these means here, because this is not in a data frame, it's in lists. Anyway, so let's take a look. So partial high school makes the least, up to graduate makes the most. This is all just dummy data. But let's now that we've analyzed the means, let's just compare pairs at a time. Let's compare partial high school to high school. So to do that, I'm going to simply call the stats dot t. There we go. I want to see if I can find it here and show you. There it is. T-test underscore ind. So this means we're going to compare an individual pair. So let's start with partial high school and then put in high school. All right, we get this t-test result object, which is a list. When you see that, let that be a little trigger that you know, okay, that means I can use this notation to say t comma p equals that. And then I can print out f, we'll say t-test or t-stat or t-value. These are all ways you can refer to the t-test result. Let's put in here the t, and then p-value right below. All right, there we go. Looking good. So this tells us the t-value, as you can see, ranges from negative infinity to infinity, like we talked about in the prior video, and then a 1.91 gives us a p-value of 0.075. So the difference between these two is not so large that we can reliably say that there's a significant difference between them. Well, let's make a histogram out of it so you can compare this to what we've done before in the past. I'm going to use, we'll use Seaborn. Import Seaborn as SNS. Let's make a SNS dot displot, and let's add in edu partial high school. So there's our values, and let's add in another displot on the same one. We'll give this a label while I'm thinking about it. Partial high school. And then SNS distplot edu high school label. All right, there we go. Let's give ourselves I won't worry about the legend for now. So we can see that these histograms are very similar. It makes sense that there's really not a significant difference between them. Let's go ahead and just take a look at the rest of them and see what they look like right now. So let's make this one You know what, now I'm changing my mind. Import matplotlib.pyplot. That's PLT, there we go. And let's adjust these right here. This is going to be partial college bachelor's graduate. All right, at the end of this, let's go ahead and give it a plt.legend. Let's see if that adds that for us. All right, perfect. So, yeah, a lot of crossover among all of them. Makes you wonder if we're really going to find a significant difference at all. But if you take a look at it, partial high school does look quite different from maybe graduate. So you can see the histograms seem to get taller and less variance down to wider spread and more variance. I see that's probably pretty typical of real life. So let's go ahead and analyze this now and see if there's really much of a difference between these. So I'm going to go back to the stats package, and this time instead of using the t-test, I'm going to use F, there it is, one way. And now I'm just going to go ahead and pass in every one of the levels of education. You bachelor's, graduate. Notice I don't have to put them in any particular order, because if you remember that formula for it, it squares the differences, and so F-stats are only, they range from 0 to infinity, and as a result, it just doesn't matter what order we put them in here. All right, so just like the T, we get this F one-way result with a statistic of 5.77 and a p-value that's quite low. So even though this looks like it's pretty, there's a lot of overlap, overall, considering the differences among all pairs at once, there really is a significant effect of education on income. And we can see that with these means obviously getting further higher and higher the further out we go, even though there is more spread. So once more, I'm going to set this equal here to FP equals that, and then print out fstat or f value, either one is fine. P value, there we go. Cool. Well, it's good to see the visualization along with the stats so that we can include them together. Something you might do is go ahead and embed these statistics into the chart and save the chart. Use this. You can use this for like a exploratory data analysis report or data understanding phase report. That's pretty useful. So this is our analysis. What we need to do next, though, is apply this to the insurance data and figure out an easy way to get the data in the right format. Easy to calculate these things when the data is in the right format, but getting it there can be a bit of a problem. So there's a few ways we can do this. There's what's called a grouped or data frame group by object. That is pretty useful. And in the book, I've got an example of that right here. And I'll leave that example in the book, but this one I find is often hard for students to grasp, and I explain it step by step. This technique is probably the fastest way to get the data in the right format, but it's also harder to understand. So I'm going to show you, let's simply filter the data frame. It's a slightly slower method, but it's probably easier for new programmers to understand. And so I'll leave that group by example in the book for you to see if you can and figure out, and then add this one as well. So let's import pandas as PD. Let's go ahead and read in our data. Let's make sure that that's reading in correctly. Looks good. Now that we have that, let's go ahead and create this visualization here. But as you can see, they're trying to phase out the disk plot. Let me show you a new one that is the one of these two that they prefer over here. I actually really like this one the best, which is why I keep using it. But Oh well, that's fine. This one gets the job done pretty well too. So we're going to use sns.histplot. Whoops. And we're going to pass in data equals the data frame. We're going to say x equals, in this case, well, charges. And then notice that on my options here I get hue. So hue is what we'll use to divide up the histogram by, let's start with sex. And let's see what that gives us here. Oh, let me not forget my semicolon at the end. All right, perfect. So we can see here it overlaps these like this, which is why I don't like it a whole lot. However, we can still give ourselves a KDE overlay, kernel density estimation, and set that equal to true. So we can get a line for each of them and see, okay, both seems to go up a little bit, and then it sort of, males have an uptick right here, and women don't. But women are more expensive at the beginning, less expensive at the end. Interesting. Men are less expensive at the beginning, more at the end. Well, that's mildly interesting. Let's take a look at smoker. Whoops, not smooker. Okay, huge difference here. Non-smokers, lots of counts down here that are low, few, very few in the high range. Smokers, few in the low range. Most of them fit one of these two bumps over here. All right, the one I'm going to focus on for, well, let's start with smoker first. We'll leave that one, then we'll come back and do region. Let's go ahead and run a t-test on this. Well, actually what I really want to do is create a function or maybe at least just a routine that will go through and automatically generate these lists like this for each value of any categorical feature that we want. So let's review, without doing it in loop, what's the manual way just to get the lists of data that we want. Well, we could say df, we could say smoker yes equals df smoker equals yes. And now we've got our filtered data frames that we can then run our t-tests on. So stats.t-test ind, and we could pass in smoker yes, whoops, and pass in charges, and then smoker no charges. All right, and that gets us, that works. That gives us a massive t statistic and a super small p-value. But I don't want to have to manually code all this. So let's do this in a way that will allow us to automatically get the values that we want. So I'm going to start with, let's make sure that we import, we've got pandas and we've got SciPy, so I think we're good. Let's do this. Let's make a groups variable. And I want to record each of the unique values of the categorical feature. So before I even get into here, I'm going to make a feature equals smoker label equals charges. All right. So groups equals df feature. So I'm passing in whatever they give me right here. And let's just print that out to see what that, oh, df feature, sorry, dot unique. Unique will give us the unique value. So let's print groups and make sure this works. Okay, good. So it looks at df smoker dot unique and gives us these values back. All right, for group in groups, now we want to have a routine that will go through and generate a list of the charges for each of those. Let's start by simply printing out group so we can see how this for loop works. So groups is my list object right here. and then this is an individual item in my list. Run that, okay, and it prints out one at a time for each group. It prints the name. So all I have to do is change this to other categorical features, and it should print out each of the unique values for each of those. All right, that looks good. What I want to do now is go through and create a list out of the charges. So let's do this. Let's say df, and then filter on that group, or sorry, on the feature. So filter on region, where feature equals group. So this is going to give me a filter data frame where region equals, for example, northeast the first time. Well, I don't want the entire data frame. I just want the label out of that data frame. So let's print this out and see if this works. And to simplify it, I'll go back to smoker. And right here, I'm going to print this. Okay, perfect. Here's a list of charges for non-smokers and a list of charges for smokers. Or maybe it's the reverse, I'm not sure here. So now that we know that this is generating the list we want, let's save it in a list. So let's, we're going to need here is a list of lists. So I'm going to call this grouped values equals, or no, not equals, I'm going to say dot append, so that I can add this item to a list. So this will go through and add just those charges as lists inside of this overall grouped values list, and that means I'm going to have to make this first before I use it. Grouped values equals a list. And then down here, let's print out grouped values. All right, so here's what I get. I've got this list right here, which ends right here, comma, this list that ends right here. Okay, we've got that. Now we just need to run an F one-way ANOVA on that. Now, here's the problem we're going to run into. We've got, in order to do an ANOVA, as you might remember, right here, there we go. We had to enter in each list one at a time. So each of these are lists of incomes. Well, we don't know ahead of time how many there are going to be. We need some way to dynamically put the individual lists in here and have any number of groups that we want. So the way we do that is right down here, we take grouped values, and by putting a star in front of it, that means take each individual list inside of that, like this one, and then this one, and add them in separated by commas as individual parameters. So this is the same as if I took smoker equals yes as a list and input that, then smoker equal comma smoker equals no as a list. Oh, I must have missed. Oh, because I need stats.f1way. All right. Huge effect size. Look, it's the exact same, at least the p-value is the exact same as our t-test. That's because the f works exactly the same as a t-test when there's only two columns. The f statistic's calculated differently, so we have a different stat here than the t-stat, but the resulting effect size and p-value are identical. Well, now all I have to do is I can just change smoker to something like region. There we go. P-value 0.03. That one's also statistically significant. Let's put in sex. Also statistically significant, but just barely. Neither of them quite as much as smoker was. So here's a nice little routine that'll go through and dynamically take any categorical feature and return an ANOVA for it. Can we turn it into a function? Sure, let's take it one step further here. DEF ANOVA, and let's grab feature label. Tab, and down here, rather than print out group values anymore, we don't need to do that. I'm going to simply return stats f1way. So let me come up here and I can delete these, don't need those anymore. So now I've got my function stored in memory. Now I can just call it ANOVA, and I'll pass in as the feature, smoker, as the label, charges. There we go. I can pass in anything I want right here. It's just a different categorical value each way. All right, so let's stop right here for statistics for categorical to numeric relationships, and we'll begin the next video by looking at some of the visualizations we can create for these.